for today, the bell ringer situation. I'll have you guys hand those in just a second. Yesterday, we discussed this and maybe more than you wanted to, but regardless, hopefully yesterday's conversation that we had was at least kind of interesting on a philosophical or historical context. Right, we talked about 360 and stuff. How far in did we go? Yeah.
For yesterday's bell ringer, I have it as something else.
So you have it as this one? Oh, okay. So here's your bell ringer for today then. And I might just put these on the board for you to talk about.
But we also did this. That's what I'm getting.
How far into detail did we go here?
We fully covered this.
Why 360?
Because the ancient.
Okay. So scratch that. Then we're good. Okay. 1017. It gets weird because I have two different geometry classes and we're slightly different places right now, and it makes it weird so they don't always match up the same.
Are they ahead or are we behind?
I mean, those are the same thing. Were you trying to trick me? Because it almost worked. I think we're like level right now. Okay, what is the hardest thing we have done this year, in your opinion? Okay, specifically with geometry, what specific thing, or things if you'd rather, do you feel you have the most trouble with? I'll give you guys like 60 seconds. There's no right or wrong unless it's just blank. If you think it's nothing, I bet I can find something where you've gotten things wrong and such. In geometry, yeah. Starts with a.
I've made the most mistakes.
What do I think? Probably proof. We haven't done a ton of them, but proof is always probably the hardest thing.
That's probably the hardest.
Or graphing stuff is another answer I'm kind of anticipating. Because graphing, like, it can be hard. That's okay. Yeah, there's a lot of stuff that we've done. Is chapter 3 hard so far? Reflections and translations? No? Good. So less good on that. I'm happy to clear up any confusions. When we do something, like, let me know where you're confused. And today we'll have time to chat and stuff. Okay. What I want you to do is, on your bell ringers, please make sure your name is on it. Please make sure the dates are on it. If you haven't been putting the dates every day, please do that regularly. You don't have to write the question, but I do need to see the dates. And then we should make a decision. Do you guys like using the file back there, or do you just want to keep them on your own bag, your book, whatever?
I like the files. I don't think. I just like the files. Just because I keep my math work.
You like the file? Okay. So my only issue with the files is that our class isn't very big, but there's obviously a lot more folders in there.
Yeah, I mean,
People's folders have gone missing.
Yeah, there's too many folders in there.
Yep, I need to find another milk crate, but deal. All right, I will take your bell ringers. If you have written down what you're struggling with.
By the way, I have like 2 of my bell ringers on homework 3.1 because I actually got the pages mixed
Okay,
up.
you're good.
I put that on there. So
Okay. Yep. Proving stuff is what everybody struggles with, eh? That's fair. You're good. All right, in the future, I don't know how I'll do this because I get it and you're not doing anything wrong, but I hate the amount of grading they're going to have to do this afternoon. With you, no, it's not. If it were just you, I'd be less, and I'm not even irritated. It's not the right word. I'm glad you're getting stuff turned in. We need to finish going through it, right?
I think this was our last one right here.
Okay, lunchtime or after school, come in and I'll talk to you about it. Cool. All right. So, awesome. Proving stuff. That's the natural answer. I completely agree with you. Today, we are going to use these graphs. If you still have them, awesome. We're going to do a little tiny bit in our notes, and it's going to be strange. We're going to go back and forth between notes and not note stuff, because you're going to help me figure some stuff out. We are doing rotations. So let's jump in here. And we'll do a couple minutes of notes, followed by several minutes. That's not our class.
It's his third hour though.
Yeah, but that was definitely, these are goofed up. All right, we're going to look at 3.3, and we are starting rotations today. Now, we saw that there are 360 degrees in a circle. It comes from Mesopotamia, and realistically, it might have been discovered before that. I wish that it was metric. And just last little comment, when I say metric, it just means powers of 10. 100 degrees makes 25-degree right angles. That's what I would have done if I got the rules. I think the same thing should have been with time. Now, we obviously can't change the number of days in a year because we're not in charge of that. A day is a day. It's 365. You could, and you could change the months much better. We should do 13 months is what we should do. 13 months of 28 days and a single holiday for New Year. Like, yes, I agree with you. But I also think that time should have been done in using the metric idea. 100 hours per day, each have 100 minutes, and each minute has 100 seconds. Obviously, what a second means would be very different in that time, but we could have done that, and maybe we should have. I think there was a push in France when the metric system was introduced where people tried to do that, and nobody was down for it, which that's okay. All right. However, in 3.3, we're going to be looking at rotations, and with this, we can all agree that there's 360 degrees in a circle. Okay. As we think about a circle, and there's infinitely many choices of a specific angle to pick in any circle, but can we all agree that there are some angles that are nice, quote unquote? Without me telling you what makes an angle nice, anybody have an idea of an angle that might be a nice angle on a circle? Can you remind me what we agreed upon?
30, 45, 60, 90, and their multiples.
So Ray remembers this very clearly. Do you guys all remember having the same discussion? Okay, so thank you, Ray, for telling me that, because I would have given that whole same spiel again. My mind at the end of the week.
I've gotten very, I don't want to be rude, but Mr. Baker does that heavily, and lately I've been getting very...
I also do it very heavily. Like,
So I've just been...
I get it. Nope. Plus, I'm getting into the old man phase. Hold on. What's the what's the word it's used with like Gen Z stuff? It's not phase, but it's something similar. Era? I'm in my old man era, which prepare for the same stories to be told over and over and over, because old people tell the same stories because they're the stories they like. Of course they tell them. Anyway, we're getting farther away from what we're trying to do. We're going to be looking at rotations, and specifically we're going to be looking at some rotations on the plane first. So let's look at rotations on the coordinate plane. Now, there's always two ways that we can view geometry, and we've seen it several times. We can view on the coordinate plane, where we start to do a little bit of graphing and algebra stuff, but we can also just do rotations and such that are just kind of floating on a plane without the coordinate system attached. So we're going to start with the coordinate plane. Now, right off the bat, we are going to work out really quickly and easily some handy rules for how these rotations work. So if you got to pick a point on here that we're going to rotate around, is there a best choice, do you think? And on here as in the coordinate plane. So negative 1, 1 is a weird, like that's what you want to rotate around? Or that's the point you want us to rotate?
Well, I want to rotate, but around is 0, 0.
Okay. Does everybody agree we could use 0, 0 as like the most natural choice, the origin for the point that we're rotating around? So check this out. We're going to start with that, and we'll come back to these in just a moment. On the coordinate plane, the very first thing, if we are rotating and we want to, it's always the easiest. So we're going to rotate in this first little piece. We'll just look at rotations about the origin. And when we say about the origin, it just means that is where we're rotating around. Okay, remind me, as an ordered pair on your coordinate plane, where would one find the origin? 0, 0. Good. Okay, now one other little piece that this is just something that we need. When we look at this, and you don't have to draw what's in pink, but I do need to make sure we talk about it. I have up on the board a coordinate plane, right, with a very clear x and a y. There are very clearly 4 different regions of this coordinate plane. We call them quadrants. Good. Where's quadrant 1? Top right, top left, bottom right?
Top right.
This is quadrant 1. Where's 2?
Top.
You don't draw this. You don't need 2. This is quadrant 2. Quadrant 3, here, and quadrant 4, here. Now, you have seen this before, and you probably don't feel weird about this. I'm going to ask one more question that relates to this for sure, but it's not going to be immediately clear, I don't think. If I tell you, like, I want everybody to stand up real quick, like physically stand up. And if you can do it without getting dizzy and throwing up, I spin like one circle and I'm dizzy, like I'm comfortably dizzy. So I don't know why. I want everybody to close your eyes for me. And I want you, without any further direction, if you're facing the front of the room, turn 90 degrees. Okay, so this worked out really well. If you guys will open your eyes, did we all turn the same way? No. Now, as I look at this, I'll tell you, your 4 was natural, yours was correct. So Ashley and Raylene turned the right way. Now, you're going to argue, like there's no real right or wrong, there's no points. You all decided a way to turn without me specifying. Which way did you turn? How would you explain, guys, apparently?
Clockwise.
You turned clockwise. Okay, natural. You turned anti or counterclockwise. The rest of the world calls it anti-clockwise. I know it feels weird. Okay, you guys can sit back down. I'm going to claim that you ladies were right. You were correct. Now, you can argue, right? You can say it didn't really matter. But if we think about with regard to algebra, why do I think counterclockwise is correct? And we've only talked about a little bit of algebra today on the board, but look at the board right now. Oh my gosh, we cycle through these counterclockwise, right? So we're just going to make one little comment, and we will certainly see this again. But positive angles, so positive, and I'll make this the same color, positive, and I can say angles or rotations. Can I just say positive degrees? That way it doesn't matter if we're talking about an angle or rotation. It implies counterclockwise. You will never see me write this again. I know that people don't always love the shorthand stuff, and I'll try my best to not do it. Anybody have a suggestion for counterclockwise? So CW is fine with me. CW in my head is clockwise, though. If we do CCW, counterclockwise. Or ACW if you prefer anti-clockwise, but nobody prefers anti-clockwise. It sounds awful. Okay, so we're always going to go counterclockwise, which, just in case somebody's hearing that and you can say it, but you don't really know, clocks turn like this. This is clockwise. Counterclockwise goes this direction. Okay, I don't know if we really had to. I'm not going to be able to get rid of that last one. And I don't know why. No, I do, and I can control Z stuff, but every once in a while, my program just kind of loses its ability to think. So that mark is here forever and ever. All right, so here's what we're going to do. You guys need these. And what I want you to pick, and we can all pick the same point. I'm good with that. Let's pick a point that is going to be very, very obvious when we rotate it. So I liked your point earlier. You said 1, -1. But I want to make sure that the x and y not only have different signs, they could have different signs. I don't really care if they do. Let's pick a point in quadrant 1 where there is a difference in x and y. And I have no preference in what we pick. I'm just saying don't pick 1, 1 or 2, 2 or 3, 3. 2, 1. Anybody opposed to 2, 1? So you're going to do 2 things. We're going to use this lovely tracing paper. Did I give you pieces of this yesterday? Okay. We're going to use this lovely tracing paper, and we're going to work this stuff out using this on that scratch paper that we have, that graph. Then we're going to formalize our rules here. So I'm going to give everybody a piece of paper. And historically, I've done this with protractors, and it's like an hour long. And we'll probably do a contract or a protractor somewhere in here. But this way is so much better than using it. Okay. Now, we are going to work out some rules here. So again, we're back and forth between notes and scratch paper today. We want to work out some rules. So I'm just going to preface this real quick. We're going to say rules for rotating. Rules for rotating about the origin. Now, as we saw with translations and reflections, there is a slight difference in the notation that I use and the notation that your book uses. And just a real quick check up here, same thing. If it's in this pink color, I don't need you to write it, but I need to make sure that we can all at least talk about this stuff. So if I write this, bless you, what am I telling you to do?
Rotating.
Am I? So naturally you think so because we're in rotations. This is a reflection. This is a reflection over which line? M. And I did write these here the other day. You might not have noticed that. I wish I hadn't pointed it out yet. This means what?
Translate.
Over which vector?
X.
A, B in this one, X, Y on that one on the board there, right? So this means just translate, go A to the right and B up. Okay, your book, when they do this, and I really do like the book notation, I just wish that they combined it with that way to do function stuff. When they want to rotate, capitals and lower cases are different letters for a reason. The way that they denote this, and I'm going to use this occasionally, they use a capital R for rotation. Lowercase r is reflection, capital R is rotation, and then the only other thing that you would need is the amount that you're rotating, right? So we'll use this notation. I'm going to combine it with mine. So if I wanted to rotate by x degrees, this is how I would write it. Okay, everybody okay with that first one? Like, whether you're okay with it or not, there's nothing that I can really do. This is it. You'll be okay with it eventually, or not. I don't know. I hope so. Anyway, let's get some rules out of here. So we are going to use our scratch paper here in just a minute, and we're going to work out the rule. So derive a rule is what we are doing. And specifically, we're going to use our scratch paper, and we've all agreed that we're going to use the point A, and what did we say it was? 2, 1. Now, I'm going to copy and paste because I'm going to have you guys work out 4 different rotations. And we're going all the way around the circle. We're going to do 4 of them total. I'm going to write all 4 of them right here. You can do it piece by piece, or you can do it all here. Now, all that we're going to do is we're going to see that if there's a general rule, it will be pretty easy to see now that we have different values. For the first one, and I'll work this out with you, but we are going to do a rotation of 90 degrees. And we're going to do this, if we don't specify, it's about the origin. If we want it to be something different, we will specify, and we'll like work that out. But we're going to do it with 90-degree rotation. What else are we going to do it with, do you think? 180. We're going to do it with 270. And then this last one, I'll show you the notation that I have traditionally used that I'm equally fine with if you don't like the capital R. I think that this, as long as I put the degrees, tells me the exact same thing. If I can show there's a mapping and it's 360 degrees, I know that we're rotating. Okay, so let's check this out. And now you could probably and realistically work out rules for a ton of different ones. We're going to simply do this first one. And it's only going to take us like 5 minutes as opposed to the crazy amount of time. So don't close your notes. Don't put them away. We're not done with them. But I am going to jump from here back to, oh my goodness, here. Okay, so if we're looking at this, first thing that I want to do, I can tell which way is up on mine because I have this here. You guys, I don't think do. I'm going to make sure I label wherever I'm graphing these, and we have 4. We can do them all on one. We can do them all on a separate one if you want. If we're looking at this, if you're using all 4 graphs, we agreed that A was 2, 1, right? And if we're going 90 degrees, we're going to work that out. Now, we can do this, and we will do this again using our protractors to get our angles out, because if it's not 90 degrees, it's not always super convenient to do. But check it out. We're going to start with A at the point 2, 1. And the very first thing, how do I get to 2, 1? I'm at the origin. What's the 2 represent?
2 right.
2 to the right, so 1, 2, and then anything else? 1 up. Here is point A. And it's at 2, 1. Okay. Now, for this, notice I have put it on here, but I'm also going to grab this lovely piece of patty paper, is what I like, hamburger patties is why you would call it that. And then I'm going to notice something. Well, gosh dang it, I can't see nothing no more. Well, okay, hold on. We can really clearly see something. Okay, on your graph, you should be able to see everything, even though the paper's here. Now, if you have point A plotted at 2, 1, I'm going to do the same thing, and I want everybody to do this. You've done so much more than you need, I think. I can't tell. Did you just trace the whole thing? Okay. You're good, but there's a much easier way. I'll get you another piece of paper if you want it. Check it out. I'm not going to trace everything. All I'm going to trace is this and this to make sure that I can line it up. And then I'm just going to plot this point.
I did that originally, but I didn't think it looked good.
So, and that's fair. But check it out. On this first one, we are trying to take point A, and we're going to work out a rule for rotating it how? 90 degrees. Now, there's an immediate issue that we have to make sure that we all agree on, and we should, but if you miss something, then here we are. I'm going to have my paper still sitting here. I only put these here, roughly, so I can see they line up. Only reason I've done it. Okay, I want to turn the top piece of paper and not the bottom. So check it out with a pen and with a pencil. I'm just going to poke right there in the middle. Now I can still grab this paper. I can do this. I need to rotate 90 degrees. I can either do it like this direction, or 90 degrees this direction. Only one of them is correct. How do we go if I'm telling you 90 degrees and it's positive? Counterclockwise. So if a clock normally goes like this direction, counter's the other way. So check it out. We're going to go 90 degrees. We're only going to do the first one together. If I turn 90 degrees, I'm not at 90 degrees yet. How do I know it?
Because you're not on the line.
Yeah, all these pieces are going to line back up when I get to 90. So here we go. Here it is. Now, it slid a little bit, so I'll just move it up. Did that happen to fall on a really nice point again? If you didn't, see what I did. I'm going to go back. Here is my original. I'm going to get a sharper pen or pencil. I'm just going to poke right on the origin, and I'm just going to turn the paper until I line back up. Now, what we are going to really easily be able to see is where this guy is. I started at A21. When I rotated 90 degrees about the origin, I wound up on another nice lattice point at one of these crosses. I'm going to hide my image for a second, but you guys should all have this on the board. 2, 1, just now with a 90-degree rotation, mapped to A prime, which lives where on your coordinate plane? I mean, I think so, but we have to make sure we agree. Raylene claims -1, 2. I agree with that. Be confident in yourself. You got it. Okay. Oh, okay. Does yours line up perfectly as well? Okay, you're good. I'd give you my glasses, but I need them. Okay. All right. Here's the deal. I want you guys to do the same thing, and you're going to get me the other 3. Now, it's going to go pretty quick. I don't care if you use the same graph and you just want to like rotate it again here. If you want to do a whole nother graph to see it, if you want to be like real specific, I can go here and write both of them here now if I wanted. A prime looks like it's at the point -1, 2. I don't care if this is on your graph. It needs to be on your page in your notes. Don't care if it's here. Okay, what if we started here instead and went 180 degrees? Or what if we started here instead and went 270? I want you to fill out these missing A prime values using that fancy tracing paper and your big old brains. Cool. I'll give you a minute or 2 if you think you have an answer or you have an answer. Check with me, and then I might ask you to extend it a little bit. I'll give us a moment. Let's check these. I think we're all in agreement, but I didn't look at literally everybody just now. If we take A at 2, 1 and we rotate it 180 degrees, where does it wind up? -2, 1. Can somebody second that for me? It's -2, +1? It's -2, -1. Okay, that feels a little bit more natural. What about A if we go 270 degrees? 1, -2? Anybody second that? Did you get something different?
No, I switched the negative.
Okay, are you fixing it on your notes? Okay, make sure you do. I think it's 1, -2. And then this last one, A prime, if we go 360, this shouldn't be weird. If you go a full circle, you wind up in the same spot, right? Okay, so here's what we see on the coordinate plane. And if you got anything different, right now is like the ideal time for us to work this out. Anybody get anything different? Okay, so with that in mind then, here's what I want us to do. There is a pattern happening, and I think legitimately we could have only done one and worked out this rule, but it's nice to be able to see what happens anytime that we turn 90 degrees. So this one in pink, it's going to be reasoning it out. And I guess before we just reason it out, let's just go ahead and see if anybody has it. To rotate, we're just going to go 90 degrees first. 90 degrees about the origin. We have, and we're going to try to generalize this completely. So I'm going to keep those up for now. But we want to rotate 90 degrees about the origin. And notice I didn't specify where we started or anything. Just 90 degrees is all that I worried about. We have the following. We're going to take an ordered pair of the form xy, and following a rotation of 90 degrees, this point will then map to its new point. I'll even say A and A prime, just to be specific. What is the rule that seems to be happening? Like if we went from this to this, and I'll switch colors here, this to this, what happened with the x's and the y's between these two? They switch places. That would give me 2, -1, right? But it's -2, -1. So not only did they switch, but something changed. The sign. And here's where it gets weird. If this is the point x comma y, we're tempted to write y comma x, which is pretty close to having it, like realistically. And I probably should have written, 2, 1, and I'm all goofed up here. Sort of goofed up. We're going to see something. Before we commit, we'll look at this one here in just a second. Let's look at this one first. 2, 1 switches to -1, 2. Did they still switch? Just like we had noticed on the other one. And they can't see what I'm pointing at, so I should probably do it here. If I go from 2, 1, x and a y, something happened. We went from here to here. And we'll see the same thing happen here, I believe. They switched places, right? And then anything else change? A -y. Now, that's a 90-degree rotation, right? So I'm pretty confident that that's there. Before I commit to writing it, and if you have written it, you're good. Like, don't stress it. But let's just see if this works again. If we went 90 more degrees, that's the same thing as just doing 180 degree overall, right? If we went 90 more, if we switch these and use the same rule, switch them, and then change the sign on the front, we would wind up with x, -y, and then I would change that sign. I would get -x, -y. Is that what happens here? -x and -y? I think so. And Ray, I'm not sure if that didn't click or if your eyes were just out of focus. Okay. So maybe, and I'll offer an alternative because xy can get kind of misleading sometimes, but I think that every single time, all that I see is that they swap places. So we get a y and an x. And then what happens with this front number? It just changes. Now every time they just swap places, and we'll just say swap, and I don't want to note, like, this is where it gets weird. We can either say x changes, but that's misleading in this notation. Can we just say opposite sign on first term? Like, because saying opposite x makes it weird because maybe you're thinking about the original x or the new one. And swap and change first sign. Okay. Now, this rule will always work. And my claim is that we probably could have gotten all of these, with the exception of the very first one, without ever having to use the rest of the paper. If these swap places from here to here, like if I wanted 270 degrees, I know that these will switch. There'll be -1, -2, and then the front number changed, and it became positive. And I can see that happened here. It happens on every single step that we knock out. Now, as we go through here, the shapes can be bigger, they can be uglier. But what we have worked out is a rule. We have done just the 90-degree rule. There are two approaches that we have. Do you want to take the time to make the same generalized rule for each step along the way? So like, how do we go from A and rotate it to get here? Or do you just want to work with the fact that 90 degrees over and over does it? And do you understand what I'm asking even?
Yes.
Do you get what I asked? Because there was a lot of words that came out really fast. So you probably do, but let's check. You do, like, up to you, and then we'll see. I'm going to switch to AB this time just so we don't confuse the X and Y. If I wanted to rotate instead of 90 degrees, what was our next stop? 180 degrees. Now, there's two ways you can do this. You could either simply do this rotation twice, right? Because that would get me to 180 degrees. Or we can try to generalize a rule. 2, 1 became -2, -1. AB then would become what if we went that far? How do we go from this to this? What's the rule that we see?
Switch signs for both.
So opposite of A, comma, opposite of B. Your guys' faces are incredibly hard to read today. You're welcome. Do you guys want these shortcuts? All 4 of them. There's really only 3 because 360 doesn't do anything. Or do you just want to recognize that 180 is just doing this twice? You know what? We're already committed. We're just going to do all 4 of them real quick. Okay. Take that, choices. What if we did 270 degrees? If we look back up at the work we did, 2, 1, switch to this. How do we generalize that? AB after 270 degrees winds up where? From here to here, what's the rule if we use A and B instead? Talk with your neighbors. A negative B? You think so? So it's okay, like, whether you think so or not. I hope you think so if that's what you said. But let's clear it up. Chat with your neighbors. If you don't understand what's happening or they don't understand, let me know. I'll come explain it as well. Now, these rules. And did everybody comfortable with how I got this? Okay, these rules. I really don't care if you have these 3 rules written. You need this one. Because what I notice is that if I had done this as negative B comma A, I know they switch signs or switch places and then the front one changes. So it would go to, if this was negative B A, it'd go to A comma negative B and then I just put a negative. And then they switch again, negative B comma negative A, and then I just switch the sign. Like repeated 90 degrees is the same thing. We could compose multiple 90-degree rotations. Okay, with this, there's nothing too crazy going on here. Let's try a single example where, like, we're gonna do it without the paper. We can confirm it with the paper, or you can always use the paper to like sketch it and stuff to get help with it. But I'd like to try just using these rules. So here we go. On our example, let's go ahead and have triangle ABC. You know what? Well, let's call it triangle BAC because I already wrote B. Triangle BAC rotates. Ooh, I'm going to throw us a curveball here. 90 degrees clockwise. Okay, that's already weird because normally we rotate which direction? Counterclockwise. So I'm going to give you a triangle BAC and we're told it rotates 90 degrees clockwise. Okay, for this, what I want you to do is find me the coordinates of triangle B prime, A prime, C prime, given the following. B is nice. It's at the origin. C, just kidding, we'll do A next, is nice. It's at -6. You guys are less obnoxious than all my other classes, so cool. Or it's getting cringier at this point, in which case I'm also good with, because it means people stop saying it soon. Bras, fam, whatever. Give me one more point. 3, 2. Okay. Now, there is a small little trick here. This is it, right? 90 degrees clockwise. Let's think about this. What's the real angle that we're going to rotate about? I guess just before. Everybody okay with 270? You say no? Yes. Okay. So instead of going 90 degrees, let's say we start here. Instead of going 90 degrees, I'll do it from your perspective. 90 degrees this way is clockwise. That's not the way we go. We would have had to start here and go like this to end up at the same spot. 270. Okay. So even though we said 90 degrees clockwise, we're going to disregard. That is simply a rotation by 270 degrees. I want you guys to find me B prime, A prime, and C prime. And we'll meet back up in just a moment. When I see 270 degrees, they swap places, and then the second number that I'm writing, or the original first number, changes sign. And that's where it gets so ambiguous to talk about it, just because it's goofy how we word it, right? Okay, this one's easy. I'm going to swap places. It's 0, 0. And then I'm going to change the sign of the second term. Do I really need to write -0? No. Could I write -0 if I wanted? Yeah, -0 and +0 happen to be the same. It's the only number where that happens. We could. Okay, these ones. We're going to swap places. So it's going to become 7, -6, but I'm not going to write it because what's going to happen with that negative? It's going to be the opposite sign now, right? So it's just 7, 6. This one, same thing, 270 degrees. It says swap places and then change the opposite value. So it's 2, 3 is when we swap them, but now this sign has to change. So now it's 2, -3. Now, the hard part of this problem is not just the sketching it, but it is always a good practice, one, to be able to plot the points. For this, if you want to sketch this on this graph paper, do so. We're going to look at one more little piece of these reflections that we need the picture. If you need a new piece of graph paper, or you just want a sticky note graph paper for this particular one, I can hook it up, but I do want to look at this graph on here. Everybody want sticky note graph paper, I would guess. Okay, I'll get that real quick. Okay, the last little piece of this, and it's not going to be super convenient to add unless you have this graph paper or you're going to tape this in your notes, but there is one more little thing that we can check. If I wanted to, and on this one, it's easy because I can see this, but if I wanted to measure the distance between A and C, is it the same as A prime and C prime? And should it be? Did my triangle physically change shape at all? No, so if I measure this distance, it's the same as this distance, right? Now this one's unique because I happen to pick a point at the origin. If we had picked a triangle that didn't have the point at the origin, however far A is away from whatever point we rotated around, like we could count this distance. Now I don't know exactly what it is, but is it the same distance that A prime is away from the point that we reflected it or rotated around also? We get distances preserved all over the place with this. Now, the only other thing that we haven't done in this section, we looked at the rules for 90 and 180 and 270. We're going to start combining and composing more of these on Monday. I want you to have a chill weekend because I want a chill weekend. Come ready to work on stuff on Monday, and I'll see you cool cats and kittens then. Get ready for snow boots.